Hello everyone, welcome to my session. Today I will talk about compound time reflection, serialization and ORM. This is the outline of my session. But first I will introduce some basic concepts about reflection. Then I will talk about the implementation and application of compound time reflection. At last, I will show you some possible application prospects. So, what is reflection? Reflection is a mechanism that gets the internal information of a class by metadata. So, what is metadata? Metadata is data that describe other data. The main feature of metadata is self-description. Let's look at some classic metadata. Look at the picture. The left picture is XML schema. The schema defines the XML elements, name, type, and the sequence. The right picture is a data table. The table also defines the fields, name, type, and sequence. If we get the metadata, we can do some interesting things. Yeah. For example, we can transform the metadata to JSON, XML, or some other format. Of course, we will use reflection to map the data. And metadata is a key point. There are some benefits of reflection. Reflection can make our application more flexible and can decouple the validity of an object and the metadata. Also, it can help us simplify our code. Next, I will give you an example to show the benefits. Yeah. This is a serialization function. If we don't use reflection, we have to write a lot of duplicate code. It's very over elaborate and error prone. We hope the code can be automatically generated, and reflection can help us do that. This is an example. We use reflection. If we use reflection, we don't write the over elaborate code anymore. Everything automatic. And we can change the behavior. For example, we can transform the object to JSON. And we can transform it to XML. And you didn't modify the object at all. So it is very flexible. Next, I will talk about the implementation of compound time reflection. In this section, I will talk about the technical thought and the concrete implementation and some limitations and proposals about reflection. Yeah, I use some modern C++ features and macros. Maybe many people don't like macros because they look ugly, right? But it can help us a lot. Later I will introduce some macros. The macros will be used later. This is the first macro. This macro helps us to count the periodic arguments. If we pass one argument, the result is 1. If we pass 2 arguments, the result is 2. Let's look at the process. Yeah, if we pass one argument A, after replacement, we will get the macro Rn, and then we can deduce the value of n is 1. When we pass two arguments after replacement, we deduce the value of n is 2. So, is that clear? Okay. Let's look. Oh, there is a detail we should pay attention, because the theoretic arguments expand manner is different between Visual Studio and GCC. So we need a wiper macro. Here we need a wiper macro to wipe the theoretic arguments. Yeah. And it is also okay in GCC. Let's look at the second macro. This macro is very simple. It's just collect the arguments. Yeah, we can collect the arguments by comma. Here. Is that clear? Okay. Let's look at the last macro. This macro helps us to make an array. And this macro will use the former two macros. The first macro, we can get the arguments number. When we get arguments number, we can define a standard array. Here, this is the n value. And then we use the second macro. This macro will collect the arguments. So we can use the string to initialize the standard array. Yeah. When we pass the T, A, and B, at last we will generate array T and has two elements, string A and B. So these are all the macros we will use later. Okay. Before I talk about the technical sort, I like to introduce some existing reflection libraries such as MagicGet, BoostFusion, and BoostHala. Let's look at MagicGet. It's really magic. You don't need to write extra code, and you can visit the field by index. It's very cool. But there are some limitations. The first limitations, MagicGet just support POD type. If you want to support all types, maybe MagicGet is not a good choice. And the other limitation is MagicGet flatters the array. That means if the object was reflected, it is different from the original object. So if you want to support all types maybe you should use BoostFusion. Yeah, this is BoostFusion. You need to define a macro, and then you can reflect the object. Yeah, you can for each the object fields and get the field by index, get the field name by index. I think BoostFusion is good enough. Maybe a small problem is that the code is not very simple, because you have to make a boost MPL range at first. Yeah, maybe we want to pass a lambda directly. Compare with BoostHala, I think Hala is more simple. Yeah, if you want to use BoostHala to reflect the object, the usage is similar. You also need define a macro, and you need pass the object type and the fields, and then you can for each the object. But there is still a small problem. Here, Bootstrap lost the sequence information. Sometimes we need the sequence information, right? Yeah, later I will talk about this point. Okay, let's look at the macro. This macro do many things and make us can reflect the object. Yeah, this is one of the 56 macros. Yeah. It is a little complicated, right? And there are 55 more macros. Yeah. My idea is similar with Bootstrap, but the concrete implementation is different. My code is much more shorter. The whole code is less than 500 lines, and Bootstrap's code is more than 3,000 lines. Last, I will tell you how to implement compile time reflection. There are two steps. The first step is to define the metadata. I mentioned before, the metadata is a key point. If you have the metadata, you can reflect. And when you define the metadata, you need to provide some operations of metadata, right? Such as get the value by index, get the field name by index, or for each the fields. And we hope our reflection library can support all types, not just POD type. Also, we expect we can visit the object non-intrusive. It's very important. You don't need to change the object. Okay, let's look at how to define metadata. I will give you a very simple example to show the sort. There is a template class member binding. This member binding has three parameters. The first parameter is the type of the field, and the second parameter is the field's reference. It's a pointer. The last parameter is the sequence. So the member binding can represent a field, and we need pack all the fields, so we use a variety template class pack to pack all the fields. Now let's look at how to define the metadata of an object. There is an object aggregate. There are two elements, and the first field is integer, and the second field is string. Now, we specialize the template class and pass the reflected object type. Then we put the field's type into the member binding. Next, the field's value and field's sequence. You can also define the field's name in an array. Now we have finished the definition of metadata of aggregate, and then we can use the metadata to feed it the internal information. Here we can print the object fields by metadata. Yeah, because we have packed all the fields in a theoretic template class, so we can recursive the pack, and we can get the name by index and the fitted value. So we have to do that. We can reflect the object aggregate, and this idea is from last year's CppCon. Here I make a summary. Yeah. The first step, save the reflected object type. The second step is pack all the fields. And we also need to define a string array to hold the field's name. And then we can visit all the fields by recursive for each. However, there are some problems. Yeah, this is the definition of object aggregate. If we want to reflect other objects, we have to write the similar code, right? So it's also very elaborate, and we hope the code can be automatic. So who can help us? Yeah, the macros can help us generate the code automatically. Yeah, these are the limitations. How to do that? The macro. The macro will automatically pack all the fields and generate a string array to hold all the fields name. And we also can provide generic for each algorithm and some other method. Yeah. Let's look at how to utilize the macro, generate the metadata. I think this macro is familiar with you because I mentioned before. At first, we need generate a string array to hold all the fields, and this macro can help us do that. The next macro is the key point: how to make the metadata. We need pass three parts of arguments. The first is the object name and the number of arguments and the arguments themselves. Okay, this is the concrete macro, and the make arg list macro is the key point. Here, we will generate a sequence. The sequence, we can collect the fields reference by comma. Then we put the sequence into a tuple. And now we can pack all the field reference. This is the user macro. You just need to pass the object type and the field, just like Posthala or Fusion. And then we can count the number and pack the field's reference into a tuple. So we have automatically generate the metadata. And the library supports 120 fields at most. Of course, you can expand the fields as you need. Let's compare with the automatic definition of metadata. Before, we have to handwriting lots of code to define the metadata of an object. Now we can automatically generate the metadata. The code is much more shorter and the usage is much more simple. Here, maybe someone thinks the C++17's new feature, structure bind, can help us to reflect an object. But I don't think so, because structure bind need the fields of the object. If you don't know the number of the object fields, you can't use structure bind. You can't destruct the structure bind. And someone use this code. At first, you have to get the fields number. It's a very difficult problem. So I don't think structure binding can help us. Okay, let's look at the operations of metadata. Here, this function can return the field number. And we use a trait to check if the object is a reflected object or not. Here I use for t. And this function will get the field's name by index. And this, we can get the value by index. So the things become very simple. This is the for each method. Because we have packed all the object fields in a tuple, so we just need for each tuple. So the sort is very clear and simple. Here I use fold expression. It's also the C++17's new feature. If we don't use the fold expression, we have to write the swap code, swallow code. Yeah, fold expression make our code much more shorter and simple. Okay, let's look at an example. This example will show how to use the reflection library. Yeah, you can get the name by index, get a value, and for each the object. Here we add the index information. It will be used later because it's useful. And the code is on my GitHub, and the serialization engine it now supports JSON, XML, message pack, and it can be extended easily to support whatever you want. But there are some limitations. The first limitation, you can't reflect member functions. You can't reflect private members because we utilize the macro to pack the fields of the object, so we can't fit the private members and functions. Now, there are some proposals. The proposals provide reflect expert and provide some method to get the private members and member functions. We need the compiler's help. Furthermore, there is meta class. The meta class is more powerful. Yeah. And we hope the proposals can become true. as early as possible. Before the proposals come true, we need a practical and cross-platform reflection library. So this is the motivation of the reflection library. Next, I will talk about the applications of compile time reflection. We can use compile time reflection to develop a serialized engine and ORM library. The serialization engine can serialize the metadata to any format, not just JSON, XML, or CppCon. Let's look at the example. Here we can use the library to serialize object to JSON and to XML or CppCon. Let's look at the code, how to transform the metadata to JSON. This is the JSON function. We for each the object, because we have provide for each method to feed all the fields. So we just for each the object, and we can get the name of the field, the value of the field. So it's very easy to make a JSON key to make a JSON value. And there is a detail we should pay attention. The field may be a struct, right? Not just the basic types, maybe reflect objects. So we need recursive to call the JSON to JSON method. It's for the listed struct. Here I use new features if const expert. Yeah, because the type may be reflection type reflected object. So make the JSON key is also very simple because we can get the field name. The deserialize function is also simple, and the sort is similar. We just need for each the object, and we know the type of the field, so we can deserialize the binary data to the field value. I want to say more about if const expert. If we don't use const expert, we have to write the enable code. I think it's ugly. Yeah, I like this feature. It's really helpful. Okay, let's look at how to make an ORM library. ORM means you can map the object to a data table, and you can also map the data table to an object. Look at the example. We query a table and map the data table to a object list. And the sort is also similar. You can find it on the GitHub, and the ORM library now has support Circlite, and I will support my circle and the Postgres circle later. This is the deserialize function. We can for each the object, and for each the row of the data table, and map the column data to the field, because you you have know the field type and the field value, so it's very easy. And you can also use reflection to generate the circle script automatically. This function is also useful because it can generate the circle script automatically. Because maybe you will change the data table. But if you use the automatic method, you don't need change the script because it can be generated automatically. So it's also very useful to develop the ORM library. Okay, next I will show you some possible prospects of compound time reflection besides the ORM engine and ORM. We can develop DSL or data binding application and the protocols adapter. Yeah, you can transform the C++ struct to C# class or Java class because you can get the field type and fields and field name, so you can easily map the C++ type to C# type or Java type, so you can use it to develop an IDL tool. You can make a DSL language use the metadata. The next possible application is data binding application. Because we have know the field's information, so we can easily generate the key value GUI. You don't need drag the controls. It's very convenient. The other application is protocol adapters. Yeah, because we can deserialize the input data, such as JSON, to an object, and then we can serialize the object to XML or message pack or some special binary data as you want. And this adapter is really useful because you can adapt different protocols. So I think there are more prospects of compiled time reflection. If you find new ideas, please tell me. Okay, any questions? Yes.
Do you know any way to have a compile time reflection on lambda closures? Lambda closure is an object, and if we want to serialize it, well, we need somehow to access it. So do you know of such a method?
Sorry, can you repeat it slowly?
I'm speaking about lambda closures.
Lambda closure.
Lambda function.
Lambda function.
But at the moment when we instantiate it with some captcha, this captcha goes to an object automatically created for us known as lambda closure object. The question is, do you know how to serialize this object or to reflect this object?
So your question is how to serialize the lambda?
Lambda closure.
Lambda closure. Serialize.
Serialize or reflect, whatever. I don't.
Oh yeah. Maybe I get your question. So you mean how to reflect the closure or lambda,
yes.
right?
Yes.
So I think maybe we can't, because the lambda is a Latimer's function.
Not. What I'm speaking about, as soon as we have lambda with a capture, then we have some data is in this lambda closure. So as soon as we wrote square bracket ABC, this ABC goes into the context of lambda. And this thing is a data member which is potentially serializable or potentially reflectable. The big question is how to do it.
Okay. Your problem is how to reflect the captured variable, right? Reflect the captured variable of lambda. Capture, because
yes.
The lambda can capture
exactly.
the
Yes,
variable.
yes. Uh-huh.
How to reflect the variables. Oh, I never think about it. I have no idea now. Okay. Any other question? Okay, thank you.